Em tela cheia.
Beleza, galera,
Prévia,
hoje é dia...
janela.
Bom, galera, hoje dia 17 temos esse vídeo maroto, hein? Estamos no horário especial, 2 da tarde, porque estamos com muitos eventos da Pax ainda para vocês. Então, lembre do comentário,
Play button.
do like, compartilhar o
Video
vídeo,
progress.
ajuda bastante o canal, hein? Vamos seguir aqui.
Play button. Pause button. Video.
Ladies and gentlemen and ghouls of the wasteland. This is Post-Apocalyptic Peer Review, Bad Science, and Fallout. How are you all doing this PAX? We are so excited to have you here. We're going to start with a little introduction. I am your moderator. I am Lexi Vanderveen. I've got my bachelor's in English and a specialty in education. I teach teenagers all day, which is basically like fighting for my life. As I pass it along to our next scientists.
My name is Andrew Garcia. I have a master's degree in organic chemistry. I think carbon is based, and I am carbon-based. All of the jokes tonight from me will be of that caliber, so I apologize ahead.
Hi, I'm Josh Licio. I have a master's in molecular bio, and I make vaccines and plants and have a lot of houseplants. They sometimes are alive.
Hi, my name is Dr. Michelle De Palma. I have a PhD in immunology, and I'm a faculty at
Caramba,
ASU,
só
and
tem
I do
mulher
some postdoctoral work
bonita nesse
still.
evento.
My background's in
Todos os
cancer and
eventos que
virus
cobri até agora tem mulher
immunology,
gata.
vaccines, specifically for viruses and parasites in plants, and that's all I got for you guys.
Aqui das americanas. Não são.
It's working now. Hi, I'm Dr. Joe Hunter, not that kind of doctor, and also not good with microphones. I am a sleepy scientist, so if I fall asleep during this presentation, you have been warned.
Please don't fall asleep during the presentation. I'm Brendan Favre. I'm a PhD candidate at ASU doing molecular and cellular biology.
Ele trabalha no Sleep Lab, aqui no laboratório de dormir.
And while we are here, we've got a whole collection of scientists that have been asked by Vault-Tec, West-Tec, Nuka-Cola, and more to peer review the science within our beloved Fallout series.
Coca-Cola?
See how much of it is accurate and how much of it is, well, open to further peer review. You could say these are the best that we have to offer, the goats of science. However, I'm pretty sure all of them skipped this part of the tutorial.
Já acho que
We
arrumou,
are
parece,
focusing on a little bit of an educational
fechar o
panel today. So,
aplicativo
of
do
course,
YouTube
at the
Premium
end, there will be time
aqui
for
no
Q&A.
PlayStation
So
e abrir de novo.
not only are we testing and challenging the science of these companies, but you can test and challenge us with your further follow-up questions, and there will be Q&A opportunities at the end of the first half. So, without further ado, quick disclaimer. You might have to be doing some thinking, and you might have to learn something. PAX and our scientists are not responsible for any damage that is caused by thinking too hard. Taking it away, let's start off.
All right, so I'm going to give the first proposal given by the reviewing the good old-fashioned Nuka-Cola company and some of their science, specifically
E falando em Coca-Cola,
just a
galera,
little bit of
eu,
background.
a
The
partir
Nuka-Cola
desse
company,
mês de
it is a
julho,
pre-war company that
vou
introduced
deixar de tomar
soda
Coca-Cola.
Nuka-Cola
Termina a
onto the market
Coca-Cola
in 2044,
da Copa,
founded by CEO John Caleb Bradburton
que eu
and
tenho
his
aqui
team
em
of
casa,
beverage
terminar
years.
todas as
Beverage years were
latas,
some of the top
já
organic
não vou
chemists
comprar
in the
mais
world,
Coca-Cola.
and their research culminated in at least 13 varieties of Nuka-Cola. Down in the bottom left, you can see pictured Nuka-Cola Quartz, Nuka-Cola Classic, Nuka Cherry, and in the right, you can see our good old CEO, Johnny Kale, as I call him, a couple hundred years past expiration date, but don't worry about
não
that.
vou comprar mais,
So,
mas
talking more
para
about
tomar
the
Coca-Cola
beverage
e
years,
tomar Gatorade.
beverage years are organic chemists. So when I bring up the phrase organic chemistry, people typically
Eu
think
lembro a
of
minha
two
mãe,
things.
se ela
Organic chemists
fazer
are known for
caso
two
omisso.
things. So first, the stuff
falei
this
pra
guy
ela.
does. Second, the stuff
Aí
this guy
lembrando,
does.
talvez,
So basically making pretty blue crystals and making explosives.
em agosto, tem
And
surpresa
if
para
your
vocês,
field is
hein?
well known for making explosives, Uncle Sam doesn't really care how good you are at making artificial cherry flavor. He just wants you to make the bombs. He just wants
Aí
the bombs.
lembrando, dia 25 temos especial
Following that, in 2076, there
do
was a
sorteio
partnership
do
between
GTA
the
6,
United
hein?
States
Fique
Armed
ligado,
Forces
hein?
and the
Se
Nuka-Cola
vai ter
Corporation
ou
under the codename
como vai
Project
funcionar.
Cobalt. So this Project Cobalt resulted in a few things. It resulted in Nuka nukes. It resulted in Nuka quantum grenades. It resulted in some very deliciously colored power armor. And actually, I don't really care about any of that. I'm not talking about that. I'm talking about power armor. It's lame. I don't care. We're talking about Nuka-Cola Quantum, baby. We're talking about Quantum, the best soda on Earth. Yeah, yeah.
Passamos la bebida
So, introduced in 2077, Quantum was a new flavor of
da
nuclear
galáxia,
with the tagline, twice the calories, twice the carbohydrates, twice
mas
the caffeine, and
nem
twice the
modo.
taste. Come on. Thank you. Anyway, so known for its patented blue glow, Nuka-Cola Quantum was and continues to be highly sought after in the Fallout universe in the Wasteland by Nuka-Cola fanatics alike and cold, emotionless robots that are not capable of alike. It is very popular. That being said, Nuka-Cola Quantum has one big thing that makes it different from all 12 previous versions of the soda. One terrible, dark secret, a secret 18th ingredient that makes it so dangerous that, in my scientific opinion, under no circumstances should it be consumed. You already paid me, you can now have this back. And that secret ingredient is pomegranate flavoring. Gross. It also has this highly radioactive isotope of strontium-90 in it, but don't worry, it's just the pomegranate
Por esse
flavoring.
motivo, Tony,
That's
que
the
eu paro de
dangerous
tomar
part, I'm telling you
Coca-Cola.
now. Yeah, there we go. So, going back, taking a step back to Project Cobalt, the weapons of Project, or the
dos
main
químicos
focus
que
of
tem
Project
dentro
Cobalt
dele.
was the weapons. It was to get these top organic chemists in the world to make chemical weapons and high-energy explosives for the United States Armed Forces. This was accomplished through the development of this aforementioned isotope of strontium-90, nicknamed Quantum, until a certain Rex Meacham, the lead beverageer at the Nuka-Cola Corporation, had this idea that the isotope could also be used to make a new version of Nuka-Cola. Make it make sense? No idea. So initial tests with the early formulations of Nuka-Cola Quantum using different isotopes resulted in anything from serious health problems to whatever that guy's doing. Don't worry about it. Their family's got cheese baskets. It's fine. However, after spending some time and working at the kinks in the formulation with the side effects went down from the level of lethal to slight headache and glowing urine territory. So I'd say that's probably a win. After that, the Food and Drug Association, not administration, association, don't worry about it, approved this soda for marketing, and it was put on the market, and then the bombs dropped, and the rest is history. So, getting into the peer review portion of their science. First things first, the first qualm I have with Nuka-Cola and Nuka-Cola Quantum is that the beverages are organic chemists. So asking an organic chemist to develop a new radioactive isotope is like asking a fast food worker to, I don't know, for a double, triple Bossy Deluxe on a raft, 4x4, animal style, extra shingles with a shimmy and a squeeze, light axle grease, make it cry, burn it, and let it swim. The answer to that is, we serve food here, sir. And by that I mean we have no idea how to do that. Like, nuclear chemistry is way above my field. I don't understand any of that. So that's my first issue. Organic chemists wouldn't be able to do that. Second issue is that adding radioactive material to a beverage, something like this, dangerous like this, has just definitely never happened. Except that, well, it happened a couple times, so not never. So in its initial release in real life, actually, in 1928, 7-Up was marketed as 7-Up, the lithiated lemon soda, implying, if not outright claiming, that it had lithium citrate in it, which is a mood stabilizer and was probably not a good thing to drink in a soda every day. On top of this, we also had things like the radium fad, where you had Radithor, which was straight up just distilled water with radium salts in it, that people used as a health tonic. But the biggest issue I have with this research from Nuka-Cola is, if we can refer back to the phrase, an isotope of strontium-90. Isotope of strontium-90. This really bothers me. It's an isotope. Okay, so isotopes. I'm going to talk about this to make it as painless as possible. Isotopes are defined as a distinct nuclear species of the same chemical element, differentiated by atomic mass. Basically, chemical elements are defined by the number of protons they have. Different isotopes of the chemical element have different mass based on the amount of neutrons they have. In that bottom right corner, you can see the isotopes of hydrogen, protium, deuterium, and tritium, each with 0, 1, and 2 neutrons on it, and an atomic mass of 1, 2, and 3. All of this is sort of leading to the point that strontium-90 is already an isotope of strontium. It is atomic mass of 90. And by definition, you can't have an isotope of an atom. It doesn't make sense. It's very flustering to me as a chemist. It's like saying you created a new chemical formulation for water. That's not a thing. Okay, so water is water. Water is H2O by definition. Water is water. You got a different chemical formula. That's not water. That's not water. You just, H2O2, nope, that's hydrogen peroxide. That's definitely not water. You got H2O4, nope, that's just two waters, just two of them. It's, okay, I'm sorry, I'm getting carried away. I have to leave.
All right, so we're going to talk about the science of the ghouls. So, I did click the wrong one. They said it would happen. I definitely did it. So imagine this. You're actually happy for once. You're frolicking. Maybe you're on a beach. You know, what's that? I haven't heard of that. And then it's Fallout, so you get nuked. It's not fun. The nukes, you die. You die. A lot of people die. The nukes studied really hard, right? They got a solid B, right? But you get a lot of ambient radiation. So even if you weren't killed by the nukes, if you're around, you're still gonna, not feel too good. So now broke the curve, solid A+, right? But let's say you're in that extra 2%. You did a good job. You're a good noodle, right? You survived. Life's good. Life's still bad. So there's going to be a lot of ambient radiation around, and if you didn't already die, it's still not going to be a fun time. So these particles are going to be damaging your DNA. It's really not fun. You're going to get all this random damage, and if your DNA is damaged, you're not going to be able to make the proteins to survive. But we do have some repair mechanisms. So depending on the different damage, you can get some repair, but it's not going to be perfect, right? If you don't have enough template DNA, you might make different repairs. It might not look the good. It might not operate as normal. So you're going to be kind of corrupted, right? But your body's going to patch it up as best you can. But even if you patch it up, you might not be looking too great. So depending on how your body patches it up, even if you're still functioning, you might not be functioning the best. So this is how we get selection, right? So we're going to have a lot of random mutations, but these mutations aren't going to be the most advantageous. So you're going to see some selective pressure, like so much radiation you might die, putting pressure on the cells to be the ones that survive. And so we actually see this a lot with cancer cells. So you're going to get a lot of ambient mutation just by being alive. Maybe you get some more UV light. You're going to have more radiation or more damage, more mutations. And so once you get a mutation that's a lot more aggressive, that cell sort of takes over and grows, and usually you get a lot of knockouts in the mechanisms that maintain, prevent DNA damage, prevent misdamage. So that increases the mutation rate, and then it selects for the cells that are most aggressive, and that's how you get lots of growth in tumors. So you get ones that survive really well, right? The kings of the missing no. So this is kind of what's happening in the ghouls, right? There's so much radiation that it's forcing the cells to mutate really fast. And you're going to get the rare cases where the cells actually become better, right? And you get the cases of ghouls, which can survive this radiation. They become much stronger than the average bear. And they're still really strong, they don't die somehow. So my theory is that they're doing so well that they're metabolizing all the radiation. So we can see this in places like Chernobyl, where we get a lot of this radiation, and there's selective pressure that the organisms there over time have adapted to survive, and some of them even go a step further and use all that radiation to increase their metabolism, right? So we're gonna say the ghouls are super strong, right? They're using all this radiation to survive. But so kind of plausible, right? Theoretically, you might have things that can mutate so far, and let's say that this, you're very, very, very lucky, and somehow you survive and become stronger. But the odds of this happening in many different cases, very, very rare, right? So we can see that, this is happening at an organism level, right? So you're gonna have multiple different people somehow survive, somehow mutate in a way that they become the same presenting ghoul, right? So we can see this in different places in the real world where different types of organisms evolve, or their species evolve in a way that they present similar traits. So we see a lot of crab-like things. But this happening with a lot of ghouls, pretty unlikely. So this isn't happening as a species, right? Normally, things evolve as a species. They're not Pokemon. So this will be one organism gets a mutation that's a little bit more advantageous, and then it passes it on to its progeny. It does this over so many times that you get these small changes. But ghouls aren't reproducing. They're not having kids that have the same traits. This is all happening in the same person, right? So this is going to be happening at the cellular level, but the odds of this happening from 2 organisms, like happening alone, probably not gonna happen. 2 different things, probably not gonna happen. And we have a lot of ghouls. So this is bad. This is not gonna happen. Yeah, but ghouls are still cool. So we'll let it go from there. Cool.
All right, so before I start, I want to invite you to try the green stuff. It's delicious. Or maybe don't, because if you don't know, what's in that big vat is what we call forced evolutionary virus. And so I'm going to be kind of evaluating that today and talking about some of the science behind it. And so what is FEV, or forced evolutionary virus? So it's essentially a plug-and-play retrovirus. So what's a retrovirus? That's a virus that can actually insert DNA into a host. So it can change the DNA. And essentially what FEV does is it forcibly mutates subjects to become super mutants, taller, stronger, radiation resistant, nearly immortal, but sterile. And also, one thing that's not listed is a decrease in intelligence. And so where did it come from? So I'll give you a little bit of background and talk about the experiments and see kind of how plausible they are or not. So it was an artificial pathogen made by West Tech, right? Or this is at least what they're claiming they've done. So it can cause changes in a genotype and a phenotype, and the goal of it was to create a virus that could essentially make an uninfected host immune to something called the new plague. And it started as something called pan-immunity virion batch 10, I think that's 10O, but it was eventually called forced evolutionary virus. And so, all right, did it work? Did that plan work? So in March 21st, 2075, on single-celled organisms, they tested what they created. And those single-celled organisms became immune to infection and radiation. Now let me ask you guys, are you guys single-celled organisms? No. Do bacteria get affected the same way, like a single-celled organism, the same way a human does? No, right? But they're claiming that it did. So then they moved forward and they were like, all right, so we saw this single-celled organism became radiation resistant. All right, so now let's look at flatworms. And they infected flatworms and they saw a 25% increase in size. And so then they were like, you know what, let's move to mice. They moved to mice, and what they said is that within hours, they're claiming that they saw a more than 30% increase in muscle mass. So this is an actual picture of their mice before and an actual picture of their mice afterwards. And so they said not only did they have an increase in muscle mass, but they also became more intelligent running through mazes. Then they finally did rabbits, and they said that in 3.2 seconds, they saw electrical activity change within their brains and increased brain activity. So these mice now are becoming smarter. And so I also want to point out, 3.2 seconds, that's so fast. It takes minutes for viruses to actually infect cells. So I'm very kind of skeptical of this research and this data, but they said it was good enough for them, let's try it on humans, right? And so that's exactly what they did. And they're claiming that, so these humans became taller, stronger, radiation resistant, nearly immortal, also sterile, and there was some decrease in intelligence. And so what happened was the US government militarized this to make super soldiers, right? And so that's essentially the conclusion here. And so could this be real, or could this be plausible? Well, let's look at the science. So let's peer review that first part, retroviruses and gene editing. Are retroviruses real? What do you guys think? Yeah, they're real. Yep, retroviruses are real. There's actually a lot of different ones out there, and they can, and I'm not gonna explain the whole diagram unless people afterwards wanted me to, but essentially they can insert DNA into a host, so it can alter your DNA. Is gene editing of viruses real? Yes, that's also real, right? You can actually edit DNA in a lab. I'm not gonna go through that whole process either, but we do know how to do that, right? Okay, cool, so then this is possible, right? Not so fast, right? There's a lot of other stuff that they're claiming forced evolutionary virus could do, right? So let's talk about genome rewriting precision. So that first part, FEV supposedly rewrites an entire genome with optimized traits. Can viruses do that to an entire genome? Probably not, right? That actually would be infection of so many cells, changing of so many different genes. It's very unlikely that you'd be able to do that with a single virus. FEV also produces predictable mutants. Real mutations usually increase via random variation and can cause cancer. And we actually know that with a lot of retroviruses that can be an unlimited effect. So I'm gonna say no to that first claim, right? All right, adult transformation. Fallout shows adults growing larger, stronger, and changing their bone structure in days. It's really unlikely that it would happen that quickly. It would take a lot longer. When you think about increases in muscle mass, there's a gene called myostatin that controls muscle growth. Even if you knock that out, it doesn't immediately cause muscle growth. It takes a long time. So it's unlikely that that would happen in days. So I say, no to the adult transformation. The last thing, immune tolerance that I want to talk about. FEV is supposed to confirm immune tolerance in an infected host, right? And so how many of you have heard about a cytokine storm? Okay, so some people. So if every cell or so many different cells are getting infected all at once, the first thing is a lot of them are probably gonna die, and you're actually gonna release a lot of immune factors. Those are called cytokines. Those are proteins that your immune system uses to respond. And you can cause a cytokine storm. So it's actually more likely that this would happen, and it can result in death of the host. And so if I was gonna actually have a reviewer decision on this grant, I think I'm gonna go with it being rejected. That is, unless I can be convinced otherwise and we can make some changes to this. We'll reconsider.
Hi, everybody. As I already told you, my name is Dr. Joe, but what you might not know is I am head of innovation at Robco Industries. All hail Mr. House. No, not that picture. All hail our beautiful CEO, Mr. House, who has entrusted me with his legacy. So you know us for our Protectatrons and our Securatrons. There's nothing wrong with these at all. They're perfect. They came directly from the mind of Mr. House, and that is glorious. You might know us for our Sentry bots and our Assaultatrons, also perfect machines. Also, Liberty Prime, one of the most brilliant creations, all of it made by Robco Industries. Don't believe anyone who says that it was a partnership with any other corporation. And you might know us for our Pip-Boys. There have been many models, all of them very well made, have not harmed any human and or animal subjects as per my new report. There's a lot of cool things about the Pip-Boys that I really love. It has this enhanced screen and a brand new UI. It has a new improved physical interface, none of that touch screen mumbo jumbo you might see floating around. It's easy to put on and take off, which is really important for getting, everyday users to pick it up, put it on, and walk out the door. And it has this built-in constant monitoring for what we call consumer health and wellness. Now, all of this was made by the glorious Mr. House, but I'm going to tell you how we, for the investors, can make this even better. We have the ability to map and track user location via both sonar and satellite. To them, they will see this as mapping a room, knowing where they're going, but to us, it's data. We have constant user biometric feedback. To them, it tells them, did you lose a leg? Do you go see a doctor, use a stem pack? To us, sweet, sweet data. Social behavior and skill tracking, item cataloging, a flashlight, which, by the way, I don't know how to monetize that. I'm working on it. And a state-of-the-art fusion battery. All of this is wonderful, wonderful data that we can pry out of every single user. We'll know where they are. We'll know what they need. Do they need medical assistance? Do they need snacks? We will know. Do they go in groups? Are they lone warriors of the wasteland? We will know. We'll know exactly what they want to buy and where they want to buy it. And this is the new glorious Robco Industries. All hail Mr. House. Approved.
You work for Robco. How can you peer review Robco?
It's fine.
I think there's one very notable entity within the Fallout universe that we haven't really reviewed yet, and that is, God bless them, the United States of American government. You know, I'm from Phoenix. It's hot, real hot down there. I woke up this morning in Seattle. Beautiful weather, beautiful country, beautiful shady trees, beautiful lane, and oh my God, they're invading Alaska. What are we gonna do? I'm panicking. There's paratroopers falling in Anchorage. I'm freaking out. But then I remember, hold up. I'm American. We have chemists, we have biologists, we have roboticists, we have power armor, we have vertebrates, we have Mr. Gutsies, we have Liberty Prime sometimes, depending on the game. Things are looking pretty good in America, but remember, I said I was a biologist, and so I'm not going to talk about any of those things. Instead, I'm going to talk about death claws, and death claws.
Jumping in, no being a furry on the panel.
Why?
13 plus.
Oh, okay. We'll keep it PG-13. Death claws. So these are obviously totally fine for anyone above the age of 13. Pre-war development by the U.S. military to replace human soldiers in close combat search and destroy missions. They're apex predators, and using the most scientifically accurate text that we have in all of literature, Napoleon Dynamite, we asked, do they have large talons, to ask if they're an apex predator. Now, stand back. I'm going to do some biology here. We can notice that there is a talon here, here, and here. So it passes that test. It's definitely an apex predator. Also, it's immune to radiation, except for when they're not. They have the intelligence at least of human child, except for when they don't. Fallout 2, anyone? Also, they have thick skin that's impenetrable to most attacks. Anyone who's played the games and had to fight a Deathclaw knows exactly how long it can take to fight Deathclaws to exhaustion. So they're pretty metal. But here's the peer review time. Deathclaws are mutated Jackson's chameleons. They have a high mutation factor, whatever that means, and they were refined by the master using FEV in some of the game, or one of the games. The Enclave also bred even more intelligent variants. But the question I'm going to ask is, how do you get from this dopey-looking lizard with the magic of DNA to this scary-looking lizard? So fun facts about our base model, the base game. It's named after this governor of Kenya from a long time ago. It looks like Ray Fiennes. It's the most interesting thing about him. They like moderately high altitude woodlands and wet forests. They like eating bugs, small lizards, and small birds and small lizards. They're less territorial than other chameleons. Does this sound familiar? Well, it should. It's the opposite of a deathclaw. These are not picky about habitat. They eat absolutely everything, and they're extremely territorial. And so the big question is, how? How did they do this? They use synthetic biology. Oh, wait, no, wait. We only have enough time to talk about a certain kind of synthetic biology. We're not going to talk about synths until maybe the Q&A if you want to know more about them. But this is more Jurassic Park than it is the Institute. And so I want to remind everyone of my favorite quote from the Jurassic Park franchise. Dr. Ian Malcolm has a really profound quote about ethics and science, and I like to remember it as, yeah, scientists should. And so, taking after Dr. Ian Malcolm, as a reminder, some synthetic biology 101. DNA codes for RNA, it's a universal code, A, T, C, and G. RNA codes for proteins, so basically it's the central dogma of biology, or central dog meat of biology. I'm sorry, I couldn't resist. You change the DNA, you change the protein, you change the organism. So we have this dopey lizard, but the question is, okay, well, great, we have a dopey lizard, how do we get to a deathclaw? I've asked this a few times now. So we go to the second most holy text after Napoleon Dynamite, and we go to the Fallout Wiki. Because I played all the games. I'm still trying to finish my PhD. My PI got mad at me. I was like, dude, just check the wiki. So I checked the wiki, and it's a genetic mismatch of various animal species. What? That doesn't help at all. Which species? So I'm going to go ahead and kind of go for broke. You have this base game, Jackson's chameleon. Hippos are some of the most territorial of all the species. You can definitely, there's some genetic components to aggression. Sure, that's plausible. Giant armadillos have massive talons, the largest in the animal kingdom. They're about 8 inches. Orangutans have family dynamics and childlike intellect. And, just for you all, PAX Show Special, 2025 show exclusive sale. I love deals. This monstrosity was made possible by viewers like you, and for only $9,301,997, you too can buy all the DLC you need to make a Deathclaw. You have a ton of caps, right? So let's combine all these. We add all these genes using some dubious methods, and we get perfection. Not quite a Deathclaw. Instead, it's probably more likely an angry, color-changing chameleon that's just going to run closer and closer to you with the intelligence of an ant, or at least a very angry lizard. We can definitely do talons, we can do territoriality, but intelligence is a little bit more sus. So if you've come to one of our previous panels before, I've done the same kind of thing where if you try to make a Mewtwo from scratch, it's not going to go very well because every one of these dots is a different protein, and this is just metabolism, not even all the other stuff. The main issue here, though, the difference between trying to make a Mewtwo from scratch and making a Deathclaw is that the Deathclaw, you have a base game. You have, like, the Jackson's Chameleon, right? So you already have most of this stuff. You just got to kind of tweak it a little bit. The biggest kind of thing with the peer review here is that the intellect, the intelligent Deathclaws, which were already controversial in canon, are questionable because there isn't really an intellect gene, as far as we know. There maybe there's a circuit. It's kind of questionable, very iffy. And so I'm gonna say it's iffy, unless the Enclave doesn't have ethics, and in game it's explained that they breed intelligent Deathclaws, right? Deathclaws. Geez, that'd be scary. The Enclave gets these, these lizards together, these chameleons together, and things are going pretty well. And maybe they notice one is more good at solving problems than others. You already have all the base game. We've done this in real life. We've made corn suck less. We've made dogs less bitey. We can make bacteria that eats plastic and poops out energy. We also, if you go to Petco, you can buy glowing fish. I've made glowing plants all the time. You can definitely tweak traits. It's definitely possible. And so if you have these kind of intelligent already Deathclaws, and it's 13 plus, I understand. We don't want to get kicked out. We want to come back next year. The Enclave, adds some FEV. Some of these, we know we can up aggression. We know we can up the Talon thing. This gets a thumbs up. You eventually get a Deathclaw that's maybe just not very intelligent. So that part's pretty real. The real life version also, we can edit genes pretty straightforward. In real life, there's trials to cure certain forms of blindness and rare genetic diseases. They've already approved a sickle cell disease treatment that uses genetic editing. And so, honestly, I'm really kind of torn about whether I should approve this U.S. government research. It's pretty complicated. It's pretty good. That's all I got.
Deve ter painel ou outro.
And with that initial portion of the presentation, we would like you guys to line on up in the middle row if you've got a question for our panel of scientists here. So if you've got a burning question to know about the Fallout universe and the science behind it, anything mentioned or not mentioned, go ahead and we'll have a microphone in the middle aisleway. You can line on up, and we'll start our Q&A session.
Okay, objectively, scientifically, Sunset Sarsaparilla or Nuka-Cola, which is better?
Give me 1 moment. This is actually a very nuanced take. You know that Nuka-Cola all the way, baby. Nuka-Cola, better, 100% better.
Thank you.
Thank you. Next question.
Nuka-Cola.
Hi, I had a question about the FEV. You said adults specifically. What about children?
Well, okay, so I'd say anything that is not, it would be similar, that it would take a long time. Is that the part you're talking about?
Yeah, mostly if you use multiple FEV type viruses and then
it would still,
that sort of thing.
And so the thing is that in order to create new mass, you need energy, right? And so in Fallout, it's like days, right? And correct me if I'm wrong on that, but yeah, it's very quick. You can't possibly get that much mass with zero or very little energy input in that short of time. So even if it was kids, it would still need to be a long time. So.
Would it work if it was a long time?
I would still say no because of all the other things that it claims that it can do that aren't possible. In terms of just growth, I mean, something isolated, like I mentioned myostatin, which controls muscle growth. It's a gene. If you guys have ever seen those pictures of, I think there was they showed the dog comparisons where there's a dog and he's totally ripped, right? Because he has a gene knockout for myostatin. That would be possible over time. Exactly how long? I would say years is my guess. I'd have to look up the exact amount of time, but that's just muscle growth, right? All these other changes are either impossible or, something that would have another issue like causing cancer. So that's kind of my take on that.
Cool, thanks.
Thank you.
Thank you.
We got buff children running through the wasteland. Our next question.
Little lamplight, kind of terrifying.
Yeah, hi. Do you think that Mirelurks would taste better than modern crustaceans, and can you scientifically prove that anyway?
You ever eat a chicken nugget?
Once or twice.
How pure do you think that meat is? You think there's no tumors in that? The Mirelurks, I feel like, are just cancer-ridden big old mud bugs and other fish. And I feel like, worst case, it'd be like a fish stick. So I would say, maybe not like Wagyu grade A5, but if you're in the wasteland, yeah, it'd probably taste as good as lobster.
I could accept that.
Thank you very much. Maybe. Next question.
Hello. I missed the very first part of this presentation, so I really hope I don't get very lucky and accidentally say something that was already said. But Brahmin trading is a huge part of the Fallout universe, and Brahmin are heavily irradiated cattle. I understand that we mentioned that with ghouls, obviously it's not likely that the mutations would be consistent across the whole thing, but because Brahmin are specifically being bred by the Wastelanders, is it completely reasonable that this stable breed of mutated Brahmin would consistently remain a source of milk and food for the Wasteland?
Yeah, could we have two-headed cows consistently?
I would say yes, because if you only have the trait of it's a cow with two heads, which already happens naturally pretty often, not an astounding amount of the time, but it does happen often enough that it's, common-ish. Then if you take that, throw irradiation into the mix, that happens more and more often, and then you just only get two-headed cows, very plausible. Because they're not really going through all the other ghoul stuff, they're not getting strong and living forever, they're just two-headed cows.
Awesome, thank you so much.
They do sometimes have dialogue, though. Next question.
Hi. What's your favorite ill-advised atomic era radioactive product?
Great question.
Let's see. Ill-advised radioactive product. It's probably got to be Radithor. Just drinking radium water sounds like as like a health tonic too. It revitalizes you. It'll give you energy. It's liquid sunshine, when it really is just slowly poisoning you and irradiating you from the inside out. Yeah, that's pretty cool. Another one is in the Trinity test of nuclear weapons testing, there was in the crater Trinitites, which was the melted glass from the extreme heat. And people after the test would like sneak on site and take some of that Trinitite, some of that cool green crystal stuff, and put it in jewelry and wear it and then get radiation burns. So that was pretty cool. Wouldn't advise wearing it though, yeah.
I'm gonna jump in just to talk about the bio side of that. I love how in ye olde times, like the late 1800s, they used to put anthrax, or not anthrax, sorry, what is it called? It's poison. Arsenic, thank you, in milk. I'm dyslexic, it's my parents' fault.
I think there was also a famous fabric dye that was made out of arsenic that gave a bunch of women arsenic poisoning.
Yeah, it was just in everything. They were like radium, arsenic, cow brains, put it in milk, it's for the kids.
I think they did. They didn't care. They were just making money,
Thank you very much.
Thank you.
So what do we think about stim packs? I know that the idea of like instant healing is wildly implausible, but what do you think about the science about like some kind of accelerated healing factor in some deployable way?
So I actually have a friend who works at a wound healing company, and a lot of what they do is it's about cleanliness, so making sure the wound is clean and adding in the different proteins that tell your own cells, hey, you need to seal this up, close it off. Stim packs, because it's an injected thing, are a little bit farther out there, but there's some really neat bandages that have a bunch of growth factors and healing factors on them that are those proteins that you'll just wrap someone's wound in, like a severe burn, and it heals a lot faster that way. So I can see in the future, especially with all of the ill-advised science behind it, they're not caring if you get cancer from your fancy bandage, that you could slap something on, have it rapidly heal. Being injected is a little more iffy, just because it would go everywhere, and no one wants that. Nah, Who needs a clean needle? It's the wasteland. It's irradiated. It's already clean. It's fine. Everything's fine.
I don't want to think about like wasteland versions of like tetanus bacteria. Ugh, it's like mega tetanus. You have like a 50-50 shot. It either heals you or you get lockjaw.
Flip the coin. Thanks so much.
Thank you.
Obviously, the stim pack just includes a tetanus cure in there to counteract it. Anyway, do you think that at some point we will see something like an actual auto doc? Not in any of our lifetimes, but a general purpose. Step into this and it can perform a lot of different procedures.
Good question. And could we have like a one-size-fits-all kind of diagnostic tool, do you guys think?
Well, it also does healing. It can.
And healing, yeah.
Sure, I think so. Like, I mean, they're already like. Thank you. Like, there are already like teledoc type things where I think it's like in Singapore there was like a doctor who was able to perform surgeries robotically in other countries. I don't see I mean, obviously I'm not a physician. I'm not trying to become a physician, but I don't see any real technical reason after a long time and a lot of innovation that like you couldn't get an auto doc of some sort. Now the question is like in the wasteland. Like, what happens to the code? Do you trust it? Also, are the reagents safe? Would you trust, like, a stim pack that's been hanging out, like, in a Brahmin barn for a year and a half to be then administered by, like, a Dr. Gutsy? I don't know.
Hello again. This is a real question. So in your bios, 4 of you listed that you put viruses into plants. And sorry, what was your degree in again?
Oh, I'm an education person. I teach English.
Okay, so
I'm just
4
a
out of
specialist in
5
befriending
of the
scientists.
doctors up here said that they put viruses into plants. Is that a statistical anomaly or is that like common for doctors?
I'm pretty sure 4 out of 5 PhDs are about this, so.
Yeah, so we could clarify, and I'm sure everyone has thoughts on this, but so we produce proteins in plants, and you do that via a plant virus, and that cannot hurt people. It's just a way of making recombinant plants. So that's like on a simple level what it is. I don't know if you guys have other thoughts to
plant bacteria using viral elements. It's also, I'm not a doctor yet. I'm working on becoming a doctor, but it is a statistical anomaly. It's not a huge field. In fact, it's getting smaller. As there are other potentially more interesting avenues to produce these proteins that we want. Plants are cool because they can they're dirt cheap for one. You just need some seed funding. You can leave it to me for the puns. The other thing is because they're big eukaryotic organisms, you can produce some really interesting things. A lot of proteins are coated in sugar. That's how your immune system, among other things, can help recognize what is you and not you, what is humans, not human. You can control that a bit in plants compared to some other organisms. But as far as statistics go, it's not like an enormous field. We just all kind of went to school together. So.
Yeah, it was, but ASU is kind of where it was based, and we all kind of came from there. But yeah.
Okay, that makes a lot of sense.
Don't believe them. 4 out of 5 scientists are putting viruses in plants.
But yeah, but if you wanted to ask more about the science behind it, I'm sure all of us later on we'd talk too much about it.
Okay.
Yeah.
Thank you.
Thank you.
So in each of the games, the vaults have some weird human experiment going on in the background. I was wondering, what is the most vault tech level of insanity human experiment that the U.S. government or some other body has actually conducted that you know of?
This is going to become a bummer real quick.
My immediate thought is CRISPR embryos, which is essentially they actually were able to splice out the gene that HIV uses to get into cells in an embryo, making those embryos resistant. And there was a lot of issues with how that was done, the government wasn't happy with that and stuff like that. But that's the one that comes to mind immediately. I do know that in the future, things like CRISPR editing in humans has been discussed, but it's something that people have been we shouldn't touch that unless it's for gene therapy and you're helping someone with a disease. So yeah, that's kind of my thoughts. I
There's
can't think of another.
Tuskegee.
Yeah.
Yeah, that was maybe. I would be surprised if it wasn't part of the inspiration for Vault-Tec. It's like you take these people under your care and you lie to them, and then they undergo horrible medical atrocities under the guise of like, oh yeah, we're trying to treat you. And then there's a treatment for syphilis that comes out during the study, and they don't tell the participants because the whole point is to see how syphilis affects people long term. I would say probably Tuskegee. There are definitely worse ones, but 13 plus.
Fair enough. Yeah, there's a lot of sadly horrible things that have happened. One of the interesting ones that I'll talk about is really an accident. So when we first started testing nuclear bombs, one of the things we did is we said, well, what happens if you nuke a bunch of ships in the ocean? And let's put a bunch of Marines and Navy personnel on ships as they would be in a carrier group away from the group that we're striking and see what happens. There's a really interesting interview with one of the people from there where he says that the bomb went off, he put his hands up over his eyes and could see through his hands. There was that much radiation. Most all of them have died from cancer, obviously. So that's an interesting accident because we just didn't really know what radiation did to people at certain distances and in certain ways, and then just, nuked a bunch of our own military personnel, which happened more than once. So that one's pretty bad and a big oopsie.
On a bit of a lighter note, less of a bummer, in Nazi Germany, hold on, hear me out, hold on. So they were investigating this chemical called chlorine trifluoride, which is a very aggressive oxidizing chemical. It's a liquid. It can only be stored in steel containers because it reacts with the steel so instantly and forms a passivization layer where it can't burn through the steel faster. At one point, some of this liquid was broken out of a vat and essentially spilled onto a concrete floor and caught the concrete on fire. It burned through the concrete. That's not something that should happen, and at that point, even the Nazis were like, we probably shouldn't touch this anymore. This is probably a bad idea. And that's the fun one.
Can you make Nuka-Cola out of it?
What kind of container would you put that in?
Steel is the only thing.
It's recyclable.
It's recyclable because steel is heavier than feathers.
Thank you for the question.
Cool, that was interesting, thank you.
So I'm curious about the origin of this panel. How did the idea come about for a group of scientists who have all this valuable knowledge that can be used to make the world better to instead take a break from that to come to PAX to talk about video games?
Well, we're a bunch of meme lords, scientists, and
free tickets.
It's really hot in Phoenix. I have to give credit where it's due. So we're all from Phoenix. Andrew moved to Seattle for grad school. But at Phoenix Fan Fusion, which is our local Comic-Con, there were some grad students from ASU that were like, hey, we care a lot about like science education. And like, if you give us like a room, just like a room off in the corner of our convention center for like the entire weekend, we'll bring in a bunch of scientists and like talk about pop culture and like science and education and try to get some outreach going. And eventually it took over an entire wing of our Comic-Con building. It's super cool. It's called Real Time Steam. Big shout out to them. And so we took inspiration from them and started pitching to other conventions. PAX was the first one we did outside of Arizona, and it is still near and dear to our hearts. We hope to continue doing it for as long as they'll keep accepting our panels. This panel idea in particular came up the first time Joe and I were on a panel at PAX. This was like 7 years ago. We had talked a little bit about Deathclaws and FEV, and we ended up getting cornered by people and talked about Fallout for like an hour and a half after the panel. So we pitch this panel every year, and now that I think Fallout is like getting their second season, we finally got to do it. So we're pretty happy to have the opportunity.
Yeah, and kind of on that note, like you mentioning coming here and talking about science, like I think most of us just love the interaction with everybody and kind of spreading some scientific truth, right? And it's entertaining too, but it's really just so much fun to talk to everyone. And like sometimes the audience will bring up stuff where you're like, oh wow, we really didn't think about that in that way. That's kind of fun. And then we all love the video games, so it's kind of just a great time all around, I think. So.
Well, that's awesome. Thank you guys for being here.
Thank you.
Thanks for coming.
Thank you.
Next question.
Hello. So since you guys are pretty knowledgeable with plants, knowledgeable generally, but still with plants, I want to know what your thoughts are on Vault 22 specifically in New Vegas. That's the vault that's completely overrun by plants. They've got sentient killer plants, all that fun stuff. I want to know your guys' thoughts.
Very Little Shop of Horrors.
That's the one where the Gek went haywire, right?
Yes, I did really light research before I got up here, and they were experimenting with some fungi. I just skimmed it, but the fungi went haywire, and then just took over.
I was thinking about this also. So the Vault 22 also had scientists in it, but its primary purpose was to preserve a whole bunch of just natural plants and plant species so that post-apocalypse they could replant and repopulate the earth with plant species that would have survived the aftermath of the fallout. But it got overrun with a fungus, and now we got killer radioactive plants.
And said scientists turned into fungi demons. I don't know how that happened.
It's the Last of Us copyright infringement.
Which Dr. De Palma might be able to talk about, because you've done some discussions about cordyceps in previous panels.
Yeah.
Oh, well, yeah, I mean, I'm thinking back on that panel. The conclusion was kind of that if it was, if you're looking at something that's like plant or fungal origin, the chances of that happening are really low because they work so differently than humans work. So that's like the Reader's Digest.
Well, there's this one fungus that can infect ants, and then it will sort of get the ants. I think it's like a chemical signal or something.
That's the one. Yeah, that's the one my panel was on.
Yeah. But gets them to move and act a certain way so it can affect things. So broadly speaking, the fungus might be able to infect people, but to get it to act that complicated.
Yeah, it wouldn't.
Yeah.
But ants are so much simpler than humans is the thing, because then they have open circulatory systems and way different immune systems, whereas we have adaptive immune systems, which essentially means we can make really specific, strong responses. So, but, it's funny, I ended that panel, or I think I ended my part of that panel saying, but the whole show started with a scientist saying that this was impossible, right? And then, so.
To kind of follow up on that, actually, the Gek uses, at least, there's not a lot about the Gek. That's why I didn't make it into this panel, actually. We were going to do Geks, but we didn't. If it's radiation-based, and you irradiate someone, and you get rid of their immune system, could you get a Last of Us situation?
Could there be ant brain with enough radiation?
Well, I think the more interesting thing, not to tangent too much on this specific question for another 8 minutes, is because there's so much radiation there, the fungus and plants would mutate so much that at some point, conceivably, they could just infect people because of their mutation, even if there's nothing with humans that's wrong.
And fungus can infect people. It's just the way that it would result, how it would hurt them is not what a lot of, The Last of Us, stuff like that wouldn't happen. Valley fever, if you guys have ever heard of it or had it, that's, you can be infected. It's just we don't react the same way as some other organisms.
Well, and it's also, there'd have to be a selective pressure to get it there. I don't know how much that the fungus growing in that little vault is going to need to be vicious, because what is it even killing? So most of it's going to just be how can I reproduce more. So, yeah.
It's got to kill the death claws.
I mean, pollen doesn't have to be vicious, so we've got allergies every year. Thank you so much for your question.
Thank you. Hi, me again.
Hello.
Sorry, I'm very curious.
You're great.
Welcome back.
So, I'm going to call your bluff. What's up with sense? Veracity. Of sense.
So, fun fact, PAX limits the number of panelists and moderators to 6 people. There was one person we were going to have do synths. They were really into synths, but they couldn't make it to PAX. Not because of the size of the panel necessarily, but that's why we didn't include it in the panel, although I wanted to at least tease it. So today, in research labs, there's significant effort underway to 3D print tissues and organs and things like that. And so the Institute, the synths are happening kind of in a little bit pre-war, then a lot after the war, and so it's totally not unrealistic to print a person if you give someone unlimited funding and 300 years and no ethics, right? So that part is totally yeah, sure, eventually. But then the question becomes, how do you then animate that person and give them sentience? The brain, at least as far as I know, I'm not a neurologist, not a neuroscientist, but as far as I understand, like there isn't like enough storage capacity, computing-wise, in the entire world to model an active brain currently. You can model like a snapshot of it, but it takes up a ton of data. To get an active brain, we don't have enough storage space yet. It'll happen. Computer scientists, I'm sure you're out there, please fix this problem so we can print people. But then the question becomes, how do you get that into the form factor of a human head? And you kind of go from there. That's like the overview of synths, I guess. Is that like the printing people part? Yes. The making them do things is a little bit harder.
Okay, thanks.
If we could build Liberty Prime with today's technology, should we?
Yes.
Yeah.
And who should have it?
Me.
Remember,
Joe specifically.
freedom is a sovereign right of every American.
Praise Mr. House.
Yes.
Thank you.
Thank you.
Hello, what do we think of the robo-brains? Putting the human brain, put it in the robot. What do we think of that?
Buds, buds.
That's something I think will one day be fairly feasible because, you know, people get injuries and become quadriplegic and things like that. So that's awful. And we have a bunch of neural interfaces that are being invented for people who are in those situations or have other disabilities. There will become a point where you can crack this skull open and just fish the brain out and put it in something else. Would that be a good idea? Yes. It would be a good idea. I think the issue more comes with once you put the brain in the jar, how do you feed it? That's really hard. Like that's really, really, really hard to deal with. And then how do you keep it safe from things like viruses? Because you don't have all of those other symptoms or systems, sorry, to keep the brain healthy. So you would take it out, plop it in something else, and then it would probably just start deteriorating immediately.
That makes a lot of sense with the robo-brains we see.
We should still do it.
You like fill it up with like a Mentats like you can in the game.
Next question.
Hi. So they're doing monoclonal antibody treatment if you already have cancer. What do you think about that for RadAway if you don't yet? Like for radiation sickness, is that where the science there is going?
Radiation is super difficult to deal with. The main issue is not necessarily anything to do with the radiation. It's all that DNA damage that Josh talked about. And what happens when your cells get DNA damage is they go, oh my gosh, I have damage, I'm going to kill myself. So you get a bunch of cellular death all at the same time. There's a really sad event that happened in Japan where they had a guy make a mistake and they were like, this man's gonna die. We're gonna use him for research in an ethical way. So they tried to keep him alive, I think, for around 2 weeks. Nothing worked, obviously, and he died. But the biggest issue is they couldn't get, a little bit 13 plus, his skin wouldn't stay on, and all the skin transplants wouldn't stay on. So it's one of those things where there's nothing that you can do with like a monoclonal antibody to treat that, realistically. It's very, very difficult to deal with. That's why nukes are scary.
And my thoughts are that the function is a little bit different because everything you were describing is really talking about, the damage that's done to, whatever it is that it was affected by radiation. Whereas with monoclonal antibodies, you're really trying to activate the immune system. So it's kind of like just trying to kill the cancer. And by making your immune cells work better. And I can, if you wanted to talk after, we could, because I don't know if we have enough time. But yeah.
Okay, cool. So it would probably kill you quicker than it sounds like.
Potentially, depending on what type of antibody you used, because there is one specifically. If you're familiar with T cells, immune cells that kill things. There's essentially cancer cells have a "don't kill me" signal, and when T cells see it, they don't kill. So the monoclonal antibody blocks that signal. Yeah, essentially,
okay.
And so it makes it kill it. So potentially, yeah, it could cause it faster. So.
Okay, thank you so much.
So I'm aware that matter and energy are sort of equivalent, and there's a lot of instances when this franchise and others of like animals like getting hit with a lot of radiation, and then either for their offspring or even within their own lifetime getting way bigger. Is there any sort of like potential mechanism or like within the scope of like scientific imagination where like some sort of organism could just like directly take that like zap of radiation and then turn it into new cells.
Energy. So it's so funny. We were talking about this before the panel when we were like, you know, pitfalling. I'm gonna let you kind of give your thoughts that you gave before.
I didn't look too much in the mechanism, but the fungus I was talking about, like it sort of evolved to use some of that radiation to enhance its metabolism. So it was something like using the particles to increase its ATP synthase or something. But that would again take so many generations because that's a fundamental change to how the cell would function. So it makes more sense in something much smaller, an organism, but for like a hippo to grow into a mega hippo, they're like something like that with a functional change would probably be unlikely, but you can definitely, if it's rounded enough, there are ways that it might be able to metabolize the radiation or use it to enhance its metabolism.
And what about the same cell is just getting bigger? Like how like for our cells, like how much, if you were to scale up the size of each of our cells?
Unfortunately, we've run out of time for questions, so we will address that after the panel. Thank you guys all so much for your participation. Please remember that PAX never changes. And if you want to see this again, or any of us again, make sure to review the panel with the QR codes and let us know what you thought. Feel free to meet us after the show so that you
Next
can
in 19, Goku revive Asu Padres close button.
and enjoy the rest of your PAX.
Invest in Nuka-Cola, thank you.
Pause, but play button, video.
Uau, galera, que evento bom, né? Tá sobre a saúde. Então, muito obrigado a todos por me acompanharem. E no próximo momento, aqui no canal da PaxFlex, no 25. Até, lembrando, estamos no horário especial.
Iniciar janela. Pesquisar janela. Adobe XP. Microsoft. Opções de OBS Studio. Interromper.